Hello all, let's start your chapter 7. Chapter 7 is the techniques of integration, and the first one is 7.1, integration by parts. Why we are using integration by parts, there is a reason. As you remember, or if you remember at the beginning of the semester, I told you that integration and differentiation, they are inverse processes. They're inverse to each other, not inverse function, inverse processes. It means it gives us a lot of meaning. It means that for every differentiation rule, I should have a corresponding integration rule. I can write this to remember, because when you study calculus, I want to see you that you are studying calculus the way that you know the meaning also. Not just memorizing the formulas. Why you are using this, I don't know why I'm using this. No, you have to know why you are using this formula, because it gets easier for you to remember. But if you just act like this, that to memorize and solve, it's not working that way, correct? And that's why I try to write everything for you. Every differentiation rule has a corresponding integration rule. That's it, because they're inverse processes. If they are two inverse processes, then for every rule of differentiation, you should have a corresponding rule in integration. For example, in chapter 6, I introduced to you the substitution method of integration. Why substitution method? When you are using substitution method, I told you that use it if you see a chain rule. When you see a chain rule, use the substitution rule. It means for the chain rule of differentiation, you have the substitution rule in integration. Look, now, if you're in a test and you see that your function is actually a chain, it's a chain rule and derivative, immediately you shouldn't go to the paper and look, okay, what should I do? If you know that much, that, okay, for the chain rule of derivatives or differentiation, I have to use substitution and integration. That's it. You know it. You don't need a table. You don't need a paper to memorize, correct? Or a note card to memorize, to learn the meaning. Now, where I can use integration by parts. Remember the product rule? When you have a product rule for differentiation, the corresponding rule of integration is integral by parts. Like this. You remember your product rule from differentiation? D over dx or d dx of f of x times g of x equals f prime x gx plus f of x g prime x. That was your product rule. Now, let's integrate both sides. This is actually the proof that I want to show it for you. You don't need to learn the proof, just memorize the formula, but see why that formula is, or why that formula exists, from where that formula comes in. I'll drive that formula for you. Integral of d dx of f of x times g of x dx equals integral of f prime x g of x plus f of x integral of f of x g prime x dx. Here dx and also here dx. When you put the integral sign, you have to have dx, right? On the left side, integral and derivatives, they cancel each other, right? You end up with f of x times g of x equals, on the right, just copy integral of f prime x g of x dx plus integral of f of x g prime of x dx. Now, let's solve this equation for f of x times g prime x dx. If you solve this equation for integral of f of x g prime x dx, you have to subtract integral of f prime x g of x from both sides. It means you will end up with integral of f of x g prime x dx equals f of x times g of x minus integral, let's put this one also in a nice order, g of x f prime x dx. This is actually the formula for integration by parts. But in this way of writing, it's a lot. Let's make it in a very simple notation, correct? That you may saw before, that simple notation. People are talking about that notation always. Let's, for example, name our f of x u. Your f of x will be u. Then du actually gives you the derivative of f of x is f prime x dx. Correct? If I solve it for du. Name g of x v. Let's name our g of x v. Then dv equals g prime x dx. Let's substitute these new names in our equation, correct? Then you can write integral f of x, your f of x is u, times g prime x dx. G prime x dx is dv. Then integral u dv, or u times dv, equals f of x means u times g of x v, that means uv, minus integral g of x, your g of x is v, times f prime x dx. F prime x dx is du. This equation that you see, integral of u dv equals uv minus integral v du, that's the formula for integration by parts. This is your formula. You have to memorize this formula. Integral u dv equals u times v minus integral v times du. Correct? Now, in an example, I'll put an example. I'll not solve the example immediately, but I will write an example for you, a problem, how to choose u, how to choose dv. It's the important part of integration by part. If you choose it wrong, it creates a lot of problem. For example, if you choose a function, that the integration is impossible or difficult, if you choose that one to integrate, it creates a problem for you. Or if you choose a function as a u, which means derivatives, correct? U is also the derivative, then it will create a problem and you cannot differentiate and say, okay, wow, now what to do, correct? It's really important for you to how to choose those parts, which one you take the derivative, which part you take the integration, correct? U Your U means differentiate or differentiation. dV is the part that you have to integrate or integration. For example, if I give you integral of, let's take a problem, x e to the x dx, correct? Which one is you have to choose as a u, which one you have to choose as dv? That's the important part. In your book, if you read your book, it's written in your book. I will give you that note, but later I'll give you really an easy way how to choose. In your book, it says choose your V such that that the integration is possible, or choose V the way that differentiation is possible. For example, in this problem, x, I will choose x as a u because I know easily, I know what is the derivative of x. And I'll use x dx as a dv because I know the integral of e to the x, correct? How to choose this? With a lot of practice, you will learn which one to choose as a u, which one to choose as dv. But let's make it easier for you, correct? It's not in your book. Remember this word. I am writing now really big here, a word. L, I, A. It should be written as a ET, but I'm writing as TE. Everyone writes this way to can pronounce, because if I put E before T, it gets difficult to relate, like difficult to pronounce, but right now, L-I-A-T-A, liate, remember this word. What does it mean? This word actually is for your you, how to choose you, correct? L represents logarithm. If you have a function, if a problem is given to you, for example, x, let's say x ln x dx. Now, your u, because L comes first, logarithm, it means your u will be ln x, right? The rest, the leftover, which is x dx, that becomes dv, correct? I represents inverse trigonometry functions. For example, if someone gives you x squared times inverse sine x dx, between these two, which one I should choose as a I? Look at the word. I comes before A. A represents algebra. Then your u will be inverse sine x. Your dv will be x squared dx. This word is actually the order, which one you should use as a u. Whatever comes first, correct? A. A means algebraic or algebra, right? For example, x squared, x, they are algebraic functions, correct? T, trigonometric. E represents exponent or exponential. But I told you, between T and E, if they come together, E comes first. Correct? Now, in an example, I will explain it to you how to choose U, or not in one example. In all the examples today, I'll explain to you how to choose U, how to choose dV, and how to do integration by part based on the formula that I just proved for you, that integral of U dV equals UV minus integral V du. Correct? Let's start with examples. Example number 1. What I have an example number 1. Integral of x e to the power of x dx. Now, remember your word. Your word was L-I-A-T-E, liate. Logarithm, inverse trigonometric functions, algebra, trigonometric, exponential. Here, I have algebraic, and e to the x is for me exponential, correct? E to the x is exponential. Which one comes first, algebra or exponential? Of course, A comes first. It means select your U as x, correct? Your U is now x. Then what is dV? The rest, whatever the leftover, this is U. The leftover will be your dV. It means your dV is e to the x dx. dV is the part that you do integration. U is the part that you do differentiation. For U, you do differentiation. For dV, you do integration. Correct? Now, if U is equal to x, what is du? What is the derivative of x? The derivative of x is 1. But if you solve, or I can say du over dx, if you solve for du, the derivative of x becomes 1 dx or dx. Correct? If dv is e to the x dx, what is the integral of e to the x? The integral of e to the x, which is v, will be e to the x again. Now, my formula is integral, correct? Integral of u dv equals u times v minus integral of v du. Correct? Now, integral of x e to the x dx equals u. What is your u? Your u is x. Times v. What is v? E to the x. Minus the integration sign. V. What is your v? E to the x. times du. What is du? Your du is dx. Wow, really easy. Now you know what is integral of e to the x. Just deal with this part and you are done. Then you can say integral of x e to the x dx equals to x e to the x minus, what is integral of e to the x? Integral of e to the x is e to the x. Because you are dealing with indefinite integral, then plus c. Right? You are done. Or here you see between these two terms, you have e to the x common. You can even go one more step. Maybe you write this way, integral of x e to the x dx equals e to the x parentheses x minus 1 plus c. Right? You can write your answer also this way. But if you do at least this much, you are okay. That's correct. This is how you use the integration by part to deal with the problems that doesn't fit your integration table, correct? Look at here, integral of x e to the x. Do you have such a rule in integration? Did you learn it in Calc 1? Explain that there's such a rule in Calc 2 in chapter 6. Can you apply the substitution rule here? Do you see the g prime? Do you see g prime here? No. If it was here x squared e to the x squared, yes. The derivative of x squared is x and it's outside. Then you don't need to go by part. You can do substitution, but it's x here. This is how you know where to use integration by part, correct? Let's do another example. Example 2. Integral of x squared sine. I will write something else here. Oh, let me put the problem. Sine 2x dx. Now, how to start? Should I start with by part? But before that, I have a question. Is this fit in your integration table? No. Is this fit? Can you do substitution? Do you see the derivative of inside, outside? Do you see g prime outside? No. If this one was 2x cubed, here, for example, if you had a 3, if it was 2 sine of 2x cubed, yes, I would use substitution easily. No problem. No need for by parts. But right now, I don't have that 3 there, right? That's sine of 2x. Then the only way is to do integration by part. Now, how to choose u? How to choose dv? You have to choose u. You have to choose your dv. Which one is u? Which one is dv? Again, your word. L, I, A, T, E. X squared is algebraic. Sine 2x is trigonometry, correct? Which one comes first, A or T? A comes first. Then select u, your u will be x squared. What is dv? dv is the rest, sine 2x dx. Sine of 2x dx. If u is x squared, then your du will be 2x dx. Correct? If dv is sine 2x, then v is, what is the integral of sine? The integral of sine is negative cosine. If it was x, it was negative cosine x. But right now you have 2x. I shouldn't explain this again here for you. You learned that in Calc 1, hopefully, that the inside is 2x. Then the integral of outside, which is negative cosine x, or cosine 2x, times the integral of inside. What is inside? If you use here, again, substitution, easily, let me show you a substitution method. Maybe you missed this or maybe you don't remember. You see, you have 2x here. Let's use another variable, for example, w. If your w is 2x, then dw equals 2 dx. And if you solve for dx, 1/2 of dw equals dx. Correct? And if you do substitution here, it means your v becomes negative 1/2 of cosine 2x. Correct? I just showed this one in this example. Like the other day I told you, I'm assuming that you are okay now with these integrations, correct? Because you did it in Calc 1. But here for this problem, I just show why your v is negative 1/2 cosine 2x. Now, let's apply our rule here. Again, your formula, integral u dv equals u times v minus integral v du. Now, integral of x squared sine 2x then equals to u. Your u is x squared. Times v. What is v? Negative 1/2 cosine of 2x minus integral v. Your v is negative 1/2 cosine 2x times du, which is 2x dx. Let's simplify. This problem is a little bit longer. Then integral of x squared sine 2x equals. Put the negative 1/2 in the front. You can put negative 1/2 x squared cosine 2x. Negative times negative gives you positive, and put here you can cancel 2 with 2. Remember, be careful, you are in calculus 2. Be careful, a warning. Can I cancel this 2 with this 2? If you do that, if it's a face-to-face class, if you do that, or if I see if you do this, I'll write definitely a recommendation letter for you to send you back to college algebra class. This 2x is the argument. You cannot cancel this 2 with this 2. Here, this 2x, yes, you can cancel 2 with 2. Then negative times negative gives you positive. Integral of cosine 2x dx. Correct? Now, again, you have integral of cosine 2x. Again, you have to use your substitution method to understand how to find this integral, correct? Then your answer is equal negative 1/2 x squared cosine 2x plus, What is integral of cosine 2x? Integral of cosine 2x gives you 1/2 of the integral of cosine is what? Sine, right? It means here cosine 2x dx, look at this part. Cosine 2x dx. Here you have to apply the by-part rule again, integration by part, because you have cosine 2x and dx. dx means 1 dx. It means you have to apply here again the integration by part. Then you have cosine, you have trigonometry and algebra. Your u becomes x. Correct? Did I miss? Yes, we have an x here. You see, I missed this x to put here. Your u becomes x. Then du will be dx. Your v is cosine 2x dx. Then dv will be, what is the integral of cosine 2x? The integral of cosine 2x is 1/2 of sine x. Why 1/2 of sine x? Do substitution again here, correct? Use the chain rule. It gives you 1/2 of sine x. Now, this part, again, you are using the integral by part formula. What is integral by part formula? U times v. It means x times cosine 2x. X times u times v. X times 1/2 of sine 2x minus integral v. What is v? Cosine 2x. I will erase here to make some space for me. Times du. What was your du? Your du was dx, right? Times dx. Sometimes you have to do integration by part 2, 3 times, right? Look at here, cosine 2x, x dx. Again, you have to do by part, right? Let me clear it here. It's written really in bad way. Maybe you cannot see. It's actually like this, cosine 2x dx, right? You have to do again integration by part. Now, let's simplify. Then this one equals negative 1/2 x squared cosine 2x plus 1/2 of x sine 2x minus, what is integral of cosine of 2x? The integral of cosine of 2x is this one should be sine, right? Sine 2x, not cosine. This one is sine. I'm copying all wrong. Here you have sine. I'm sorry. You have sine 2x. The integral of sine 2x gives you negative or 1/2 of cosine 2x, correct? And plus c. This was a longer problem. I'll try to do a lot of them, and If you have more questions, you can use my office hour, then I can explain it again to you, right? Let's do another one. Let's do another easier one. Integral of x sine x dx. Again, your word. L, I, A, T, E, liet. I have x and sine x, algebra and trigonometry. Definitely your u will be algebra or algebraic. Then your u is equal x. Du equals dx. Your dv is the rest. Sine x dx. Your v will be, what is integral of sine x dx? Integral of sine x dx is negative cosine x. Now, my formula. Integral of u dv equals u times v minus integral v du. That's my by-part formula. Then integral of x sine x dx equals u. Your u is x times v. That means times negative cosine x minus integral v negative cosine x times du. Your du is dx. Put the negative outside, then you can say it's equal negative x cosine x. Negative times negative gives you positive integral of cosine x dx, correct? Which is equal negative x cosine x plus, what is the integral of cosine x? The integral of cosine x gives you sine x. And because you are dealing with indefinite integral, plus C final answer. Correct? Now, what if you have a definite integral? For definite integral, let me put a formula. I don't need to prove it again. If you are dealing with definite integral, for example, integral from a to b, if you have integral from a to b, u dv, then this side becomes u times v from a to b minus integral v du, but your integral from a to b. That's the formula if you are dealing with definite integral. Correct? Let's do an example. Integral from 0 to 1 inverse tan x dx. Correct? Dx is actually, you have, represents the algebraic one. Inverse tan x is your inverse trigonometry, correct? Again, your word, L, I, A, T, E. I representing the inverse trigonometry, A representing algebra. Okay, inverse comes first. Then your U will be tan inverse or inverse tan x. Then du equals, what is the derivative of inverse tan x? I just proved it the other day for you. The derivative of inverse tan x is 1 over 1 plus x squared, right? And you have to put dx here. Now, your dv is dx. Then v is what? If dv is x, what is the integral of dx? The integral of dx is x, right? Again, calculus 1, the integral of dx is x, right? Now, let's put these parts in our by part formula. My formula, again, I'm writing here, your formula is integral from, if you have integral from a to b, u dv, it's equal u times v from a to b minus integral from a to b v du. You see, if you remember, because you have bounds here and you do substitution, actually, you have to change your bounds also, correct? Now, if your u is equal inverse tan x, when x is 0, then u becomes tan inverse of 0. What is tan inverse of 0? Tan inverse of well, let's do it later for you, not now, because you will get confused everything together. Let me do it later for you. Let's plug in these values at least here. Now, I can write integral from 0 to 1 inverse tan x dx actually equals u times v. What is your u? Inverse tan x times v. What is v? Times another x minus, from where to where? From 0 to 1 minus integral v, which is x times du, 1 over 1 plus x squared dx from 0 to 1. Now, this part you can plug in 1 and 0 in your x's, or you can rewrite, you can do in the next step. This one equals, you can write this x at the beginning, x tan inverse x from 0 to 1 minus, if I write this one in a nice way for you, right? This one becomes integral of 0 to 1 x over 1 plus x squared dx. Oh, what is integral of x over 1 plus x squared? That's important to remember. Do you see the derivative of your denominator somewhere? The derivative of x squared is x. Then immediately use substitution. Correct? To do not get confused, I will not name it u. I'll use another letter, for example, t. My t will be 1 plus x squared. Then dt equals to x dx. That means 1/2 of dt equals x dx. Correct? I'll use substitution here. Now, I have bounds. Let's change the bounds here. It's much easier. When t is equal 1 plus x squared, when x is equal 0, then t equals 1 plus 0 squared, which gives you 1. Again, when t is equal 1 plus x squared, when x is equal 1, then your t becomes 2. Now use substitution here. Then you can do like this one equals x inverse tan x from 0 to 1 minus integral 1 over, instead of 1 plus x squared, you can write 1 over t because you named 1 plus x squared as a t. Instead of x dx, you can write dt. From where to where, you change the bound from 1 to 2. Now, x tan inverse x from 0 to 1 minus what is integral of 1 over t? Integral of 1 over t, hopefully you remember, integral of 1 over x is ln x, correct? Or ln absolute value x. Then integral of 1 over t will be ln absolute value of t from 1 to 2. Here plug in 1 upper bound, lower bound. Here plug in upper bound, lower bound. And also here you have 1/2 of dt. Put your 1/2 here. That's it. You are done. Which is equal x. Plug in the upper bound. It means 1 times tan inverse x. It means tan inverse of 1 minus x 0 tan inverse of 0 minus 1/2 ln of absolute value of 2, correct? Minus ln of 1. Tan inverse of 1, which angle the tangent is 1? Pi over 4. 0 time inverse of that angle, it doesn't matter. 0 times something becomes 0. It means this part becomes 0. Then pi over 4 minus ln of 1 is again 0. It means minus 1/2 of ln absolute value of 2. Correct? Or you can write in a nice way, this way, which is pi over 4 minus ln absolute value of 2 over 2 final answer. It's basically the same way. But you see, even when you are doing integration by part, again, you are using substitution. Again, you are using simple rules of integration. You have to remember all of them. How to use it, even you are doing by part, but in a part of by parts, it comes substitution method, correct? I will stop the lecture here, but your lecture doesn't end. Just practice with this part. I'll put part 2 for this lecture, and I'll cover those types of the problem that it's coming as a repeating, how to deal with that one. There you will know the beauty of integration by part, that it helps you a lot. That the problem comes back, you do few steps, but you see your problem again there. How to deal with those types of the problem, and also I will do a proof for the deduction formula for sine. I will do that proof and we will do some examples. But for time being, I will stop the lecture because it's too much. And I'll make another part for 7.1, correct? Just practice with these problems, do some. The lecture is not done yet. And I'll put the part 2 of the lecture also in your canvas.